Solar Storm 2025. Are we on the brink of a modern Carrington event? In April 2025, a stark warning issued by NASA reverberated through the scientific community and beyond. A filament eruption on the Sun had hurled vast clouds of solar particles directly toward Earth. The agency cautioned that this could ignite a G2-level geomagnetic storm, a moderate but potentially dangerous disturbance of Earth's magnetosphere. While this may seem like just another hiccup in solar weather, scientists are growing increasingly uneasy. Why? Because 2025 marks the peak of the current solar cycle, and this eruption could be a prelude to something much more severe. The question on everyone's mind, from scientists to emergency planners, is chillingly simple. What if the long-feared superstorm finally arrives? What if a solar event rivaling the legendary Carrington event of 1859 hits us in the age of satellites, artificial intelligence, electric grids, and global dependence on electronics? Could modern civilization withstand such a blow, or would we plunge into a technological dark age in a matter of minutes? Fire, what is happening on the Sun right now? To understand the current threat, we must begin by looking skyward to our life-giving star. The Sun is not a static ball of fire, but a roiling, seething sphere of plasma undergoing cycles of magnetic activity. Every 11 years, it reaches a peak in what is called the solar maximum, a period marked by increased sunspots, flares, and coronal mass ejections, CMEs. Right now, in 2025, we are either at or near the very peak of solar cycle 25. This cycle, which began in 2019, has already surpassed expectations in terms of intensity. In the past 12 months alone, scientists have recorded multiple X-class solar flares, the most powerful kind, dozens of M-class eruptions, which can still cause significant disruptions, enormous filament eruptions, ribbons of solar plasma that can span hundreds of thousands of kilometers, CMEs that have repeatedly slammed into Earth's magnetosphere, raising proton levels and triggering moderate storms. In April, one such filament tore away from the Sun's surface, flinging a massive cloud of plasma directly toward our planet. This event triggered a G2 geomagnetic storm, capable of disrupting communications, GPS, and even power systems. While still considered moderate, these storms are increasing in frequency and intensity. Globe with meridians, a civilization built on electricity and vulnerable to the Sun. Unlike in 1859, humanity in 2025 is utterly reliant on electronics. Nearly every aspect of modern life, from global finance and communication to air travel and healthcare, depends on technologies that are vulnerable to solar activity. The risks of a major solar storm: GPS deviations, positioning errors up to 10 meters or more, transformer damage. Overloaded transformers could cause widespread blackouts lasting hours or even days. Satellite disruption, loss of satellite navigation, timing, and communication services. Aviation chaos, flight rerouting, cancellations, and grounded aircraft due to unreliable navigation systems. Communication blackouts, HF radio and emergency communication systems could go silent. Power grid failure, like the 1989 Quebec blackout, which left 6 million people in the dark for 9 hours due to a G2, G3 storm. Imagine a world where the internet is gone, cellular networks collapse, air traffic control is blind, financial markets freeze, and electronic payments stop working. Grocery stores run out of food. ATMs don't function. Emergency services are crippled. The very fabric of our interconnected digital civilization begins to unravel. Compass nature unplugged, wildlife at risk. Beyond human technology, nature too could suffer. Many animals, from migratory birds and whales to bees and sea turtles, use the Earth's magnetic field to navigate. A powerful geomagnetic storm could confuse their internal compasses, causing birds to fall from the sky or land in unfamiliar places, whales and dolphins to beach themselves, bees to abandon hives, unable to return, land animals like foxes and wild boars to stray into cities. It's a haunting image. Skies filled with auroras and birds fluttering down in disarray. As disoriented wildlife stumbles into human spaces, the boundaries between nature and civilization begin to blur, much like in Hitchcock's The Birds, but this time driven by solar physics rather than fiction. High voltage, the shadow of history, the Carrington event. To grasp how severe a superstorm could be, we must look back to September 1859, when the sun unleashed a fury unlike anything seen before or since. This was the Carrington event, named after British astronomer Richard Carrington, who witnessed an enormous solar flare from his observatory just hours before chaos erupted across the globe. What happened in 1859? Telegraph systems worldwide failed or caught fire. Auroras were visible as far south as the Caribbean. Sparks flew from telegraph machines, even when they were unplugged. Some telegraph operators reported being electrically shocked by their devices. Newspapers of the time described the sky as ablaze, with auroras visible in broad daylight. This was a world where electricity had just begun to enter everyday life. Had the Carrington event occurred today, scientists estimate the damage could exceed $2 trillion globally, with years of recovery needed in some sectors. Globe showing Europe, Africa, Earth's magnetic field, the unsung hero. The only reason we are not constantly bombarded by harmful solar radiation is thanks to our planet's magnetic field. Generated by the movement of molten iron in the Earth's outer core, this magnetic field acts as a protective shield, deflecting charged particles and channeling them toward the poles, where they create the mesmerizing auroras we sometimes see in the night sky. But this shield is not invincible. It can be compressed, weakened, and distorted by powerful solar storms. And there is growing evidence that Earth's magnetic field is weakening slightly over time, particularly in the region known as the South Atlantic Anomaly. Mars, for example, lost its magnetic field billions of years ago, and with it, its atmosphere. The result? A barren, radiation-blasted desert. While Earth is not facing such a fate anytime soon, the comparison is a stark reminder of just how much we rely on this invisible force field. Crystal ball looking ahead. Are we ready? Despite decades of warnings from scientists, the world remains ill-prepared for a true solar superstorm. Many transformers are still unshielded. Air traffic systems lack solar weather redundancies. Spacecraft and satellites are only partially hardened against intense radiation. And yet, preparation is possible. Hardening infrastructure with shielding and surge protection. Improving early warning systems using satellites like NOAA's Discover and NASA's SOHO. Creating international protocols for space weather emergencies. Educating the public about risks and emergency preparedness. Perhaps most importantly, we must invest in monitoring the sun, understanding space weather, and treating solar storms with the same seriousness we reserve for earthquakes, tsunamis, or hurricanes. Shooting star conclusion. A fragile civilization under a fiery star. We live in a golden age of technology and comfort, powered by invisible currents and guided by satellites orbiting 35,000 kilometers above our heads. Yet all of it, our planes, phones, food logistics, emergency services, even our sense of time, is tethered to a star 93 million miles away. That star is beautiful, vital, and dangerously unpredictable. As solar cycle 25 peaks, the chances of another Carrington-like event rise. Whether it hits this year, next, or decades from now is uncertain. But one thing is clear, it will happen again. The question is not if, but when, and whether we'll be ready. So the next time the auroras shine over places they shouldn't, or your GPS seems a bit off, remember, the sun is watching. And sometimes it reaches out with a fiery hand that can shake the earth to its core.